Hi, everybody. I'm here to help you with Chapter 3 of your beginning algebra course, which is on mathematical models. Basically, I'm teaching you how to solve word problems. That's my goal. And at Lakeland, we feel that solving word problems is one of the most important things we do in our beginning algebra class. Many of you will go on and take statistics. You'll be taking other classes where the most important thing you got out of your algebra class is your problem-solving ability. Your ability to apply mathematics is more important than your ability to push x's around. So I want to see if I can help you with that now. So here I have section 3.1, using a problem-solving strategy. And I'm going to help you with a few of these problems. The first thing I'll point out, they say approach word problems with a positive attitude. I love it. You want to be successful in anything in life, approach it with a positive attitude. So you guys can read this on your own time, but I completely subscribe to that philosophy. And then here they give a little how-to, which I think is really nice. They really do understand in this book the steps for solving problems. I'm going to write it as a 5-step approach rather than 7 to solving word problems. And I'd like you, when you do the homework, try to use this 5-step approach. As a matter of fact, you're going to see when I solve the problems, I'm going to use Roman numerals, and I'll list a little Roman numeral to the left as I work on a particular step. So step 1. And this corresponds to their steps 1 and 2, actually. I think that's important to see. So I'm going to tell you to read and try to identify what the problem is asking. So let's say, what am I supposed to find? That's your first step. Your book listed as 2 steps, step 1 and 2. You don't read a word problem like you read a novel. You read it with a purpose. What am I supposed to find? That's really what step 1 is all about. Step 2, I like to say we like to define the variables. This corresponds to their step 3, where they say name what we are looking for and choose a variable to represent that quantity. I'll put the variables, the S in parentheses, because we'll start doing problems with one variable, but sometimes it's easier when you have more than one, as we'll see as we proceed through the course. Now step 3. This corresponds to their step 4, translate into an equation. I just say write an equation. Actually, I'm going to do one more thing. I'm going to put a little S in parentheses. Sometimes you'll write equations. The basic rule is however many variables you use, that's how many equations you want to write. At the beginning, it's going to be 1. But down the road, we may do more than 1. And I really like their advice in their step 4 about how you do this, write an equation. It may be helpful to restate the problem in one sentence with all the important information, then translate the English sentence into an algebraic equation. You're going to see me model this as I do some examples for you. Once you're done writing the equation, you can probably guess what I want you to do next, right? I want you to solve the equation. And I guess I'll put an S in parentheses again. Sometimes you'll have more than one equation down the road. Again, that corresponds to step 5. And then the final step, which I guess I would put 6 and 7 together, okay? You need to answer the question that's asked. Just because you can solve an equation doesn't mean you're done. X equals 3, okay, but what does that tell us? It depends. We want to go back to what you're supposed to find and make sure you answer it. So these are the 5 steps. And I thought what we could do is work through some examples. Actually, of course, their examples have the old show solution feature. So I think I'll do some of the you try it's. I thought I'd do some of the even problems. And by the way, when you're studying, I would suggest get in the habit of having the answer key open. So remember, after the be prepared, then we have some you try it problems so that you can quickly go back and forth and check. So you just open a separate tab and you can have the answer key and the problems open at the same time. That's better than a regular book. All right. So here we go. 3.2. Let me write down step 1. Read and what am I supposed to find? So as I read this, I don't even start with the sentence 2/5 of the songs. Here's what I do. I look at the question mark. See that question mark there right after playlist? Let me read that sentence. If there are 16 country songs, what is the total number of songs in the playlist? So I didn't even read the whole problem yet, and I already know what I'm supposed to find. Okay? Find the total number of songs in the playlist. Now, I did step 1. I'm ready for step 2. Define variables. The way we do this, at least the one method we use, is we use what are called let statements. Let x, you don't have to use x. You could use a different letter if you want, but this is probably the most common variable used. Equal. Now really, the way you should read this is let x represent, and x, of course, when we say it's a variable, it represents a number. So you should say what it represents, and you can use step 1 to help you. It's going to represent the number of songs in the playlist. Now, as I said, sometimes you'll have more than one variable, but for now, it's just a single variable should take care of things. So now it comes down to writing an equation, step 3. Now, I'm going to read more carefully now the word problem. And I'm going to try and translate it a little bit. 2/5 of the songs are country. I know it said in Mariel's playlist, but I kind of feel like that's probably enough. 2/5 of the songs are country. Songs in the playlist, right? Maybe I'll be a little more clear. And so now it comes down to translating, and the book actually has you practice this a little bit in chapter 1. So if you find that you go through this homework and you just need more practice with this step 3, this may be the hardest step, by the way, go ahead and practice this using some of the examples in chapter 1. So let's see, 2/5. I can tell you that the word of in mathematics means times. Almost always. Like if we say 50% of something, that would be times 1/2, right? 1/2 times. So 2/5 of the songs in the playlist, well, X represents the number of songs in the playlist. So I'm going to say 2/5 times X. The verb usually translates into equals. 2/5 of the song are country. 2/5 X equals, and country, do we know? Oh yeah, they told me in the second sentence that there are 16 country songs. So there are 16 country songs. So did you see how I did that? I now have 2/5 X equals 16. So that's the equation I'm going to try and solve. And so I'm on to step 4. Solve the equation. Now, by now you should be able to handle this if you've worked through chapter 2. But anyways, we're trying to get the X by itself. We have a 2/5 we're multiplying by, and so the trick is, if I multiply by the reciprocal 5/2, everything will cancel, and I will get an X, because I'll have 1. 1 times X is X. But the rule is, whatever you do to one side, you must do to the other. And now I'm going to ask, well, can you write 16 as a fraction? And the answer is you can write it as 16/1. And so if you multiply on this side, you would get 80 over 2, or maybe the easier way to do it is if you cancel, 8 times 5 is 40. So either get 80 over 2, which gives you 40, or you cancel and get 40. So that's step 4. And now we're on to step 5. We need to answer the question. What's the question? Find the total numbers of songs in the playlist, so I can use that to guide my answer. There are 40 songs in the playlist. How about that? Our first word problem is solved. I think we need some more examples. So let's go ahead, fold this up for a minute, and we'll try and use the 5-step method to solve another. Let's try, you try at number 3.4. Jerry worked Sudoku puzzles and crossword puzzles this week, blah, blah, blah. You know what? I'm wasting time. I should do step 1, read and just write down what I'm supposed to find. I'll go to the question mark at the bottom. How many crossword puzzles did he do? So find the number of crossword puzzles. I guess when it says he, maybe I should go back and see who is he. Oh yeah, this Jerry. Jerry did. Okay, step 2. So it looks like Jerry did Sudoku puzzles and crossword puzzles. Well, since I don't know how many crossword puzzles Jerry did, I'm going to say let X represent the number of crossword. You know what? Maybe I'll use C for the number of crossword puzzles that Jerry did. And if you wanted to use 2 variables, maybe you would say let S equal the number of Sudoku puzzles. This might be overkill for now. I think this problem ends up being pretty easy as I was looking over at it. But this is the kind of thing you can do. Step 3. Now, if I have 2 variables, I'm going to need to read and write 2 equations. So it says the number of Sudoku puzzles he completed is 8 more than twice the number of crossword puzzles. So that's the second sentence written in this kind of choppy format, which I'm telling you can help. You see, I have a number here and I have a number here, right? The number of Sudoku puzzles we're representing as S. The number of crossword puzzles we're representing as C. Is equals. So we have an equation. S equals. Now how do you translate this? Well, this would be C. But when we say 8 more than twice C, so twice C, that would be 2 times C. And when we have 8 more than, you would write plus 8. By the way, if it said 8 less than, you would write minus 8 because it would be 2C, but then 8 less than that. This is 8 more than that. Okay? Now remember I said that you need to write equations. If you have 2 variables, you need 2 equations. The next sentence actually gives me the second equation. It said he completed 22 Sudoku puzzles, so S is 22. So I am cheating and teaching you how to work with more than one variable during the very first couple weeks of this class, but it's just a convenient thing to do. This is called substitution. If you have more than one equation and you have one of the variables by itself, we know that S equals 22, so I can come over here now and I can write 22 is 2c plus 8. Now, I think that your book, when they demonstrate it, they would take the words I wrote here in step 3, and they would immediately, since there's 22 Sudoku puzzles, write that is 8 more than twice the number of crossword puzzles. So if you got read directly, that's great. If it helps you to write two let statements and 2 equations, then now you've seen how to do it. Okay, step 4, we need to solve this equation. So I need to get the c by itself. So I'm going to subtract 8 from both sides. And now I get 14 equals 2c. And I'll divide both sides by 2. And I'll get c equals 7. So again, step 5 is to answer the question. And I will just say, Jerry did 7 crossword puzzles. Okay, so I hope you're getting the hang of this 5-step approach. It takes practice. We will keep working. Let's try another example. Number problems. Let's try number 6. Okay. Actually, a problem like number 6, you're going to think that this 5-step method is overkill because it says find the number, right? That's what you're supposed to. What am I trying to find? Find the number. Okay. Step 2. Let n equal the number. Let n represent the number. Step 3. And this is the kind of thing that you probably would practice in chapter 1. The difference of a number and 11 is -7. Remember that word is means equals. So something equals -7. What is it? The difference of a number and 11. Well, n is the number. And what does difference mean? Difference is the answer to a subtraction problem. So I hope you understand step 3. And from here, step 4 is to solve the equation. And then step 5 is to answer the question. The number is 4. Good. Let's move on. Here we are. Section 3.8 is next. You try it. Well, steps 1 and 2 are exactly the same. Find the number, let x equal the number. Let me try step 3. Step 3 says the sum of 3 times a number and 7 is 25. Sum is the answer to an addition problem. Is 25. Now, what are the 2 things that we are adding together? 3 times a number and 7. So if I did what I did up here and said let n equal the number that we're trying to find, then 3 times a number and 7, there's the equation for 3.8. 310 is very similar. But I'm going to work it out because I feel like 310 is one of those problems where it's probably easier, since you have to find 2 numbers, it's probably easier to do this problem with 2 variables. Here's how I would approach this most likely. Let x equal 1 number. Let y equal the other number. So now I'm ready for step 3. So again, since I did 2 variables, I'm going to need 2 equations. The first one, and you can probably get pretty easily, the sum of 2 numbers is 58. The second one says one number is 4 more than the other number. Sometimes students really have a tough time translating that second sentence into an equation. So I'm going to see if I can help you. One number is, most people are okay up to there. Now, it says 4 more than another. So here's my question. If I put a y here for the other number, is this true or false? And you're going to say that's false. They're not the same. This one is 4 more than that one. So how do you make them equal? Which one's bigger? Let me ask that first. Well, x is bigger because it's 4 more than y. How do you make them equal? If you add 4 here, now you have the correct equation. So that's good work if you understand that. If not, it may take some work. You can write it down for now and at least see if you can do step 4. Once again, I have x by itself over here. X equals y plus 4, so I can come to this spot, and where it used to say x, I can substitute. I can put a y plus 4 where the x used to be. And just write everything else down the same. And so this is an equation that's a little more complicated than some of the other ones we've had to solve. Not too bad. Y plus y is 2y. And now I'll subtract 4 from both sides. 2y equals 54. And I'll divide both sides by 2. And I'll get y equals 27. Now I'm supposed to get both numbers. And notice, once you have y equals 27, you can come back to the equation you had before and substitute. Because again, y is 27, so x is 31. And so now my step 5, I'll say the numbers are 27 and 31. So there's section, or problem 10. Okay, we have a few more to do here. I'm going to skip 12, it's a lot like 10. And 14 is as well. We're going to move on to these consecutive integer problems, and so the next one I'm going to try is number 16. So again, when you read problem 16, you're asking, what am I supposed to find? So step 1. It says find the integers. Now, what are integers? I can explain that pretty easily, I think. Integers are positive and negative whole numbers. In other words, you're not allowed to use fractions. 0 is also an integer, by the way. Now, one thing that makes this problem different than some of the other number problems we had is that it said you see the word consecutive. So step 2, we're going to let x equal the first consecutive integer. Now, I don't know if you know what that means, consecutive. That's really the key. So 2, 3, and 4, that would be 3 consecutive integers. 7, 8, 9. They have to follow each other. If you have negatives, which we may, -5, -4, -3. These are sets of 3 consecutive integers. So I'm going to let blank equal the second consecutive integer. And I guess the question is, if x is the first one, how would you represent the second one? I'm going to recommend we don't put y, because it's a very simple relationship, right? I mean, if my x is 2, what would I write down for 3? Or if my x is 7, what would I write down for 8? And I claim that what you're going to put is x plus 1 is the second consecutive integer. X plus 1. And I hope that makes sense. So now, step 3 here, it says the sum of 2 consecutive integers. Remember that the sum is the answer to an addition problem. So x plus the integer x plus 1 is -31. You could take these parentheses away if you want. I was just kind of noting that that's what you have. And if you took them away, now you can do what's called combine like terms. 1x plus 1x is 2x. You can actually only add like terms. And now if I subtract 1 from both sides, I'll have 2x equals, now that when I say subtract 1, you have 31 to the left and 1 more to the left, it's 32 to the left, so you get -32. And so to finish, this is all step 4 I'm working on right now, right? All the solving. To finish, I would get x equals -16. And so now I'm ready for step 5. The integers are, well, here's where it can help to look back at step 2. See, if x is the first consecutive integer, the second integer you get by x plus 1. So that's -16 plus 1, and that's -15. So this is my answer to problem 16. I think 1 or 2 more ought to be enough. But I hope these examples are helping you feel more comfortable with and understand better word problems. Find 3 consecutive integers whose sum is -36. Well, I'm not going to work out the whole thing. I will just tell you that problem 18, step 3, you would do something like x plus x plus 1 plus x plus 2. There's your 3 consecutive integers, is -36. So that would be your step 3. Let's move on. Yes, problem 20. Find 3 consecutive even integers whose sum is -24. So this is interesting. What do we mean by finding 3 consecutive even integers? Well, 2, 3, 4 doesn't work anymore. 7, 8, 9 doesn't work because they all have to be even. So let's suppose I start with 8. The next even integer is 10, and the next one after that is 12. So this is an example of what an answer might look like. So since there's 3 integers, I'm going to do this. I'm going to let x equal the first integer. So let's suppose x is 8. How would you get 10? Well, you would let x plus 2 be the second integer. How about that third one? Can you guess? X plus 4 is the third integer. And I think actually from there you should be able to finish problem 20 and you can check your answer. Okay, moving on. Last one I'm going to try with you is number 22 using the 5-step method. Step 1. What am I supposed to find? Let's take a look. I go right to the question mark. So the last sentence, I haven't read it all yet. It just says, what was the median price of a new home in November 1964? Find the median price. By the way, the word median, it's a statistic that represents the middle. It's a kind of average. So think of it as the average price, the median price of a new home in November 1964. So that's a long time ago. But that's what I'm supposed to find. So the first sentence says, well, maybe what I'll do, by the way, before I read the first sentence, I'm going to let M represent the median price of a new home in November 1964. So M represents that. Okay. Step 3 is to write an equation. Let's see if I can do it. It says the median price of a new home in the United States in November 2014 was $280,900. So I think it might be useful to kind of jot that down. November of 2014, the median was $280,900 is the median price. Then it says, this was $10,700 more than 14 times the price in November 1964. This was, remember, was is going to be equals $10,700 more than 14 times. Are you guys okay if I just put an M here? This was 10,700 more than 14 times the median price of a new home in 1964. So I'm telling you that this phrasing of that sentence is going to help me get the equation. Again, I believe step 3 is the hard. I think step 3 is harder than step 4. Translating the problem, attacking it. What do we mean by this? Well, this $280,900, if that's the median price, that's what goes here. $289,900 was 10,700 more than 14 times M. So take your 14 times M. Are those equal? No. This one's bigger than that. How much? Well, 10,700. So if I add that to this side, now I have an equation. And that's step 3. I think you guys can do the rest. So I know this video took some time to watch, a little over a half hour, but I hope you found it helpful, and I hope you're able to get better and better at problem solving.